Hey guys, I'm Kirby561, and this video is going to show you how to use an editor tool plugin I wrote that allows you to generate a C++ controller for a widget blueprint from within the Unreal editor. This can save a lot of time typing out widget names, so you're able to reference them from C++ and add your own custom logic. You can get the plugin code from the GitHub repository I linked in the description. I actually rewrote a previous implementation of this from scratch based on feedback I got from the Unreal Engine subreddit, so thanks for everyone that replied to my post there. I really appreciate it. So I'm going to get started by showing you how to use it. I have a pretty basic project up right now, it just has a empty basic level here. And I'm going to start by creating a folder just for our UI widgets. And if I open that, I'm just going to make a menu blueprint here. Which is a pretty basic thing to do, so WBP menu. If I open that, let's just start by putting a canvas here. And we'll give it a few buttons. So there's a button, there's another button, there's another button. And we can add some text to these. So let's say we're gonna have a start button, an options button, and an exit button to start here. So we can make this say start. Make this say options. And make this say exit. Okay. And then just make these sized correctly. So one thing about this plugin is everything you want to reference needs to have a name. So let's just start by naming our buttons. This will be the start button. This will be the options button. And this will be the exit button. So if it has the default name, it won't show up in the controller that gets generated. Okay. So super basic menu here. You can play with the look of this all you want, but I'm not going to spend time on that right now. So we're just going to save this and compile it. And now if I go back to the actual file, WP menu here, if you right click, you'll notice when you have the plugin installed, you get this menu here, scripted asset actions, and you can do WBP create controller. So I'm going to click that, and you get a menu saying, where do you want this? So you can put this wherever you want, but I'm going to make a folder in my project called UI controllers. And we'll just put it here and then hit create class. Now you're going to get a dialog that comes up, and this is going to compile the new class that you're adding. And one of the nice things about this plugin is once this is done, it's going to automatically reparent that menu blueprint to the newly created class. So once that's done, we're all set. And if we go to our project in Visual Studio Code here, you can see on the left we have our UI controllers subfolder, and we have a menu controller here. So if I click on the header file, and I scroll through here, you can see that it inherits from user widget. It has the whole uClass body already. It's got a constructor. It has a create instance method, so we can easily create one and add it. We have a property section, and these are all the buttons that I named here. So notice the canvas isn't here because I didn't give it a name, and neither are all of the sub text widgets. We just have the buttons that we gave names to. So we have a start button, an options button, and an exit button. You notice it also has the correct class here. And it also generated a loader class. This is how create instance creates the class, and it has the widget path that it grabs. So game UI WBP menu. If I go to the CPP class, you see it automatically included button because we're going to need that. And other than that, it's just an empty constructor. So let's add some code here. So let's say that we want to do something when you click the start button. So you can edit this. Just don't touch any of the generated sections or they'll get overwritten the next time you update. But for the moment, let's make a section for event handlers. And I'm going to say ufunction void on start button clicked. And we're going to call this method when the start button's clicked. So let me just define that right here. So menu controller on start button clicked. And let's say that we want to just call a function when this gets clicked. So I'm going to include functional here. It's just a standard library header. And let's make a method that that our game code can call to basically give a callback for when the start button is clicked. So we'll do void add, say add event listeners, SE function on start button clicked, and we want this function to just be void and take no parameters. So we can implement this in our controller as well. Just paste that definition. And UI controller, add event listeners. And then the last thing we're going to need is a member variable to store that in. So below properties here, I'm just going to add the same function declaration for on start button clicked listener. So we're going to set this back in our CPP file to whatever the caller passes in. So start button clicked. And then when the actual button is clicked, we're going to call that function. So on start button clicked listener. And now all we need to do is hook this on start button clicked U function up to our start button. So we can do that right in our add event listeners method here. You could also have an initialize method you call if you'd prefer that. But what we're going to do is get our start button by the reference that was created by the generator, so start button. And we're going to get the onClicked event, add dynamic, and we're going to add this is the target, and the function is UmgController on start button clicked. Okay, so now we have some custom code here that we can add a callback to that start menu, or that start button rather. If I go back to our player controller, let's add our menu when you start the game. So I'm going to go to the header file, and we're just going to make a section here. So class UmgController, and then we're going to go to the CPP file and include the header file. So include UI-controller / menu controller. And then in begin play, we want to first create the menu. So menu controller equals UmgController create instance. And we have to give it a player controller, which is this. And this is that same create instance method that the generator created for us. And then let's set our event handler. So menu controller set event listeners. And we want to capture this. Remember, it takes a lambda. And it takes no parameters. And all we want to do when this gets called is we'll just hide the menu for now. Let's say that that starts the game. So menu controller remove from parent. And then we want to add it to the viewport as soon as the game starts. So menu controller add to viewport. Okay. So now we just need to build and run this. And it says set event listeners is not. Oh, it's add event listeners. So fix that and go again. All right. So now when I run this, I should just get a menu that pops up. And it's pretty ugly, but here it is. And if we hit start, the menu goes away. So now let's say that we want to create a more interesting options button. So I'm going to make a new widget blueprint here called WBP Cool Options Button. And if we open that, we're just going to have it be a button with text still. But we're going to have the background color be, let's say, red. And let's increase the text size as well. So we'll just call this options still. And we'll rename our button to Cool Options Button. Compile that. And now just like before, we can right click and say create controller. And we can put it in the same UI controllers folder that we put the menu. So now if we open our main menu back up, we can delete the existing options button. and add the one we just created. And we'll just leave it with the same name except without the prefix. So we can save and compile that, and you'll notice that we get a required widget binding isn't there. So this makes sense because we just changed the name. So let me close that, and I'm gonna right click and say update controller. And we get a little green menu tick that says it's been updated. So let me close this real quick and just show you what that did. So if we go to our menu controller, you can see in the header file, it replaced that old options button controller with this new cool options button controller. And if I go to the CPP file, you can see it even found the header file and included that as well. So we actually don't need to do anything, just rebuild here. And you can see now if we go back into our menu widget, if I save and compile, you see there's no longer an error about the binding. So you can change these however you want and then update them later, and you don't have to retype new stuff that you add to it either. Well, the next thing we want to do is, let's say you were refactoring your project and you wanted to move where this menu was. So let's say that instead of it being in UI, we want it in the menu folder. And we'll drag and drop our menu there instead. And now let's say we do some work on it and we want to update again. So we say update controller. And now we get this message saying it couldn't find it. So internally, the plugin keeps track of where all the source files are in a file called, if we go to the tutorial project folder, there's a file called blueprint source map. So if we open that, see this keeps a table of all of the widget blueprints that it knows about, where they are, and their corresponding header and C++ file. So we could update this manually here if we wanted to, but there's also a tool we can use. If I go back to our Unreal project, if you right click, you can say update mappings. So click that, it says mappings updated. And if I were to look at that source map file again, you can see now it says game menu widget blueprint menu instead of game UI. So this will automatically update that mappings file for you, so you don't have to go in manually. Although you always can do manually if anything ever goes horribly wrong. So now if I right click and I say update controller, it says menu updated. So if you do have to move widgets after the fact and you get that error trying to update, that's how you fix it. Alright, so in the next section, I'm going to show you how to actually install the plugin, if you're not familiar with how to do that. So let me close this down. And back in VS Code, I'm actually just going to delete the whole plugins folder for the moment. Okay, so now if we open up that link in the video description below, see it goes to this GitHub. You click on code, download zip, it'll download the repository. So you can open that folder and just unzip it somewhere. And this is the whole plugin file folder. I'm just going to rename it to not include the branch name at the end, but if you were to open this up, this is all of the plugin code. So all we have to do is copy it, open up your project folder, make a plugins folder, and paste it in. So now all we have to do is run the project and we should be able to enable that plugin. So I'm gonna build and run. And then if you go to Edit, Plugins, and Other, you should see the plugin show up, and just check the box to enable it. And that should be all you have to do. And then if you right-click any widget blueprint, you should then see the Scripted Asset Actions menu show up, and you'll have those options that we were just using throughout this tutorial. So that's it for how to use everything. If you like these tutorials, please subscribe and like the video. I'd really appreciate it. And the last thing we're going to do in this video is just talk about how the plugin actually works. So if you're not interested in that, thanks for watching. If you are, we'll get into that. So this is the starting point for our plugin library. If you watched my previous video, I explained how to create plugins and how to set up the C++ backend for them and everything, and how to put them in the context menus in the editor. So go check out that video if you haven't already. But you can see we have our three functions: create controller, update controller, and update mappings, and this is what gets called from those context menu commands. So I'm just going to do a brief overview for how these work, because this is actually pretty complicated. But if you look at this code generator class, this is where most of the magic happens. So we have at the top of this header, create files and update files. If I go to the CPP file and scroll to the top, you can see the basic strategy here for creating is we have these two templates, the header file template and the CPP file template. And we have all the boilerplate for those classes written here. And we have markers in these templates for things that can change between widgets. So for example, the header file is different. So we have header file name as a marker, and we can change that depending on which widget you clicked on. And we have the widget name, widget suffix. And if I scroll down here, these markers are defined as well. So we have the name, suffix, path, and file name. And then in our create files method, first thing we do is we throw up that create file dialog you see when you hit create files. So we have a class called uFileCreation process here that we start. And this basically throws up the dialog, and when the user selects files and hits OK, it will call this lambda. And in here we start with our header file template. We replace those markers that we just looked at with what the real values are that are passed in. And similarly with the CPP file template, we start there, we replace the markers, and then we have these two update methods, update CPP file and update header file, that actually fill out all of the properties and the includes and the create instance method. So after we do that, we trigger a compile, and when it finishes, if auto reparenting is enabled, then we auto reparent the class. So you see that's down here. There's this UBlueprint editor library, reparent blueprint. And then after we reparent, we save. There's actually an issue if you don't do this, it doesn't save automatically. So if you were to restart the editor without doing this, then you lose your reparenting. So that's in a nutshell how this works. The other interesting thing that it does is to come up with the list of headers. It actually parses a manifest file that gets created by the build process. So if I open our tutorial project folder and I go to intermediate build Win64 tutorial project editor debug game, you can see there's this manifest file, tutorial project editor UHT manifest. And if I look at the contents of that, you can see this actually for every module in the project spits out the base directory and the public header files, the private header files, and even internals. So we basically parse this file. If I look all the way down at the end, you can see our project, tutorial project, and you can see all of our header files are in here. So we basically parse this file, pull out where all the header files are, and then we remove this base directory, and the remaining path is the path to the header. And what's nice about this is it gets our header files, and it also gets the header files for all of the dependencies of the project. So that's how it gets where, you know, the button header is, and if you had other things like the text widget, it would pull all that stuff in automatically as well. So this works pretty well. And in the code for this, we have a manifest model, and this just matches that JSON structure exactly. And it has the array of modules, and so for each module, we have the JSON structure for that in here as well. And then we have a header lookup table that basically loads the file, uses this model to interpret it, fills out all the headers, and if we look at back in code generator, that update header method, update header file. Let's see down here somewhere, or excuse me, not in the update header, but an update CPP file rather. You can see it makes a uHeader lookup table, and then it uses that lookup table to find the include path. And then the only other thing in here is that blueprint source map I was talking about. When you actually hit update file, if I go back to our plugin library CPP file, so when you say update UMG controller, it uses the source map, it loads the mappings, it finds the blueprint in there, and then it uses this to find the actual header and CPP file locations to update. So that's what that mapping file is used for as well, and that's pretty simple. It's just the JSON file in the project with a big table in it, and that's how it finds header and CPP files. So I'm not going to go into gory detail of how this works, but that's how it works at a nutshell. If you have any comments, you can submit questions on the GitHub issue tracker, or if you find any issues, submit them there as well. And I'm using this in a game that I'm developing, so I will be submitting updates as I find, if I find any crashes or bugs or anything, I will be updating this repository as well. So stay tuned for updates to that. So with that, thanks for watching, everyone. Once again, really appreciate if you like and subscribe if you like the content. So thanks everyone, and have a good one.